In this lecture, we are going to learn several special curves. The first one is parabola. Parabola probably is the first curve that, as the graph of a function that we have learned. This is the graph of quadratic function, and in general, the parabola actually, if you look at how the curve behaves, so you have a straight line, which is the blue straight line, and then you have this dot. So you have the straight line and you have the dot, and the red curve is the curve where they have equal distances between from the curve to the line and to the point. So every point on the curve have the same length. If you connect the curve, connect the point to the focus, the fixed point, or you go perpendicular to the line, they are equal distance. And that's how you find how parabola is formed geometrically. Okay, so when you have the line and the point, you are able to fix this parabola. Rather than our old definition, they're quadratic, right? The graph of quadratics. So looking at parabolas from this structure, what you have is the point, the fixed point is called focus. We have the focus, okay, the point, and the line. The fixed line is called directrix. And again, when you have the point and the line, which are the focus and the directrix, you can form this parabola. And when you go from the focus to, let me use another color since we already used red. From the focus, if you go straight to the straight line, you go perpendicular to the straight line, the midpoint on this line segment is on the parabola because equal distance, right? That's where the point has the same distance to the point above the focus and the same point, same distance to the directrix, which is the other point, end point of the line segment. So this point, midpoint, actually is on the parabola, and meanwhile, if you look at this line segment or the line, this line segment is on, this is the axis of symmetry of your parabola. So it is called the axis of the parabola in general, and that point on the axis is called the vertex. Okay, so this is the third thing, vertex, we're looking at. And when your directrix is horizontal, you have the equation x squared equals 4py. Okay, so if your directrix is horizontal, if your directrix is parallel to x-axis, then x is squared. And similarly, if you have the directrix that is vertical, then you will have, which is parallel to y direction, then you will have y squared, okay, in the parabola. And also the focus, we go back to the graph. This graph has equation x squared equals 4py, where the focus is 0p. If you think this point is 0, if you think this point is 0, 0, let me again use another color. If this point is your 0, 0, this point will be 0p. And the horizontal line, the directrix, will be y equals negative p. Similarly, when you are having the vertical line and a point, then you are having this equal distance, it's here and then probably like here, so you will end up with a parabola this way. And if you set up your coordinate plane at the vertex of the parabola, which will be here, this will be P0, and this will be x equals negative P. Of course, this is when P is greater than 0. The graph will be, since your directrix is vertical, you have y squared equals 4px. Or you can think this is the graph that does not pass vertical line test. So it's not a graph of x, but it is a graph of y because it passes horizontal line test. And when p is less than 0, well, I'll do the sideways case. So let me use the same colors. If the directrix is vertical, but the point is on the left of it, then still you connect them, you get the middle point. Or I set up my axis, and this will be the origin, because that's where the vertex of the parabola is, and so look this way, where this is still P0, this is 0, 0, and this is x equals P, but this time P is less than 0. Oh, sorry, x equals negative P. P is less than 0. Okay, so if you observe parabolas, in summary, parabola is the point that has equal distance to the focus, which is a point, and the directrix, which is a fixed line. And when you look at the parabola, there is a vertex, which we set as the origin. Then the graph, if the parabola is open upward or downward, you would have x squared equals 4py. If the parabola opens sideways, you would have y squared equals 4px. And the focus has p in the coordinates. Okay. So again, if your focus is on the y-axis, it will be 0p. If the focus is on the x-axis, it will be p0, no matter positive or negative. Now let's see some example. Given the equation x squared plus 8y equals 0, we want to, well, we know it's a parabola, okay, by assumption. Find the focus and directrix of the parabola and sketch the graph. So you just need to move it, make it to the standard position of parabola. Now the parabola's standard position will be the perfect square equals the other term. So this will be x squared equals negative 8y. And compare x squared equals 4py, right? That's the formula, and that's what you have. So 4p equals negative 8, or p equals negative 2. Okay, so p equals negative 2, and you have x squared term, which means this is a parabola open upward or downward. P is negative 2, this is the focus. And when p equals negative 2, the directrix will be positive 2. Let me make it dotted. So y equals 2 will be the directrix. Okay, so vertex is 0, 0, always. And the focus will be P0, 0p in this case, 0, negative 2, because you are having x squared term. So it's either open upward or downward. And it opens toward the focus. So this is how it looks like. And what else should I say? The directrix is y equals 2. Okay. I don't really ask you to draw the parabola that really have equal distances, because that's really hard to draw. But just give me the, you have drawn so many parabola shapes. Just give me one that is round, look like a U shape. That's good enough. Well, same thing. We are sketching this graph. 2y squared equals 5x. We want focus and directrix, and then we want the graph. So isolate the square. Y squared equals 5/2 x, and the coefficient is 4p. So p equals 5/2 divided by 4, or times 1/4, which is 5/8. And you have y squared term, which means this is sideways. So here's the plane, and parabola is sideways. I have the focus, which is 5/8. This is 1. Let's call this is 1. Then this is a little bit more than half. So here's the 5/8. And p. So this is -1, and this is the -5/8, which gives you the directrix. The single term, the one that without the variable that doesn't have squared, is, pretty much equals to the -p. That's the directrix. So we have focus, which is 5/8, 0, and then I have the directrix. I place it on the x coordinate. This will be x equals, then the opposite, -5/8. Finally, graphing it, I'm having the vertex here, and this is a parabola open, this way. So that's the parabola. Next example, if I describe the parabola and I want to get the equation of the parabola, what should I do? Well, you sort of, sketch the graph a little bit if you want to, or you pretty much just find p and know which way. Is it a sideways parabola, or is it upward or downward parabola? That's all you need. So if you sketch the graph, actually it might be easier. So here we have the vertex at 0, 0, and x equals 4 is the directrix, which means -4 will be the focus, and this is the parabola. But actually all you need to care is, well, what's p, and is it in x or is it in y? Directrix is x equals -p. So, but meanwhile, x equals 4, so p equals -4, and the variable in directrix is the variable that is not squared. So we have y squared equals 4px, which will be y squared equals 4 times -4x, which is -16x. We'll draw the graph a little bit. This definitely is y squared equals 4px, right? Because it's sideways, is y squared. Then you figure out x. Figure out the p. All right, now you can try practice number 1, number 2. Next type of graphs is ellipse. So ellipse is you get parabola by fixing a line and the point. You find equal distance, the points that has equal distance to the line and the point, right? So for ellipse, you get them by starting from 2 points, and then all the points on the ellipse, if you look at the total distance to the 2 points, is a constant. Okay, so an ellipse is the set of points in a plane, the sum of whose distances from 2 fixed points f1 and f2 is constant. So what it says is, for all of these points, p f1 plus p f2 is a constant. And what that constant is, actually, if you keep reading, the x-intercepts are a and -a a0 and negative a0, because that's where y equals 0, okay? And then the axis, the y-intercepts are b and negative b. If the graph have equation x squared over a squared plus b squared over, y squared over b squared equals 1. So what's the total distance? The total distance is from this point, go here and here, right, as straight line. If you replace this little red piece by this red piece, if you ignore that, you are really just having 2a. You're not connecting the major axes. So that's why it is 2a. Actually, not only that, the x-intercepts, but also any point on the ellipse. If you look at the distance from the point P, which is a random point on the ellipse, to the foci, then you are going to have, and you add up the two distances, it's a fixed number, which is 2a. Note that in an ellipse, you have both x and y squared. Okay, both x term and y term are squared, and between them it's a plus. And when on the right hand side, of course, is 1, then you compare the two denominators, the square root of the two denominators. The higher one has major x's, and the lower one has minor x's. So what I'm saying is, if a is less than b, well, we don't really write that way. If we have x squared plus b squared plus y squared plus a squared equals 1, because actually, I don't need the square. Actually, this is a higher number. The denominator of y squared is a higher number, then the major and the minor axes will switch, because you always have the denominator of x always contributes to the x-intercepts, and denominator of y always contribute to the y-x and y-intercepts. So this time you will have bigger y-intercepts than x-intercepts, which means you are going to have a ellipse this way. Now, the foci. The foci actually happens where, you sort of have a Pythagorean theorem. Do I want to tell you why? Maybe not. But, you sort of have the Pythagorean triple kind of thing. So the A pretty much the A here and the B here and the foci always somehow form a Pythagorean. By this I mean because later we are going to do hyperbola, which it happens very similar. So for ellipse, A is the longest, foci is inside. Okay, so these are the two focuses, the 2 points, which are, these are the foci, which are like each of them is a focus. And the focus happens at C equals square root of a squared minus b squared. If this is A and this is B. So you take the difference of the two denominators and then you square root. That's where the foci happens. And the foci happens on the axis of major axis, the longer one. And of course, when A and B are equal, you are going to have a circle. If A equals B, then the two foci shrink into 1 point, because A squared minus B squared equals 0, so you get to the center. The foci and the center all overlap together. You have a circle. Okay, same thing. We want to convert the equation to the graph, and then we want to describe the graph and find the equation. So we need a 1 on the right hand side. Let's just divide everything. Equals 144. So I divide 144, 144, 144. So the left hand side will be x squared. Well, you do the calculation. This part is 1/9 plus this part, you can cancel the 16. Y squared over 16 equals 1. So 16 is higher, which means your graph will look like this. Okay, major axis will be y-axis, on y-axis. All right, then my a squared equals 16, a equals 4, which means my vertices is on y. It's on y-axis, or really is realized on the y-coordinates. And then I want the vertices, I want the foci, so the foci will also happen on y-axis. C squared equals the longer, higher denominator minus the lower denominator, which is 7. So C equals square root of 7. And the foci will be plus or minus square root of 7. And then I have the vertices, and the minor axis happens b squared equals 9 and b equals 3. So the minor, the other two intercepts happens at 3 plus or minus and 0. So if you think this way, when you make my x 0, I lost this term. I have y squared over 16 equals 1, where the numerator equals the denominator. Y squared equals 16, so y is plus and minus 4. Similarly, when I look for x-intercept, y equals 0, I won't have x squared over 9 equals 1, where x squared equals 9. So going back to the graph, this is something that's hard to do on a screen. So I'm having a 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. So these two are my vertices. This is where my minor axis is, and I connect them to get a, well, this is not really the best ellipse that I can draw, but again, it's very hard to do it on the screen. And the foci is radical 7, which is between radical 4 and radical 9. So the point is between 2 and 3. So these are the foci. Next example, I give you the key information, foci and vertices of the ellipse, and I want to recover the equation. So vertices is the major axis, which means it happens on x. So a equals 3, that happens on x. Then c equals 2, which means b equals the major axis minus the foci, c squared. This is 3 squared minus 2 squared, or 5. Oh, sorry, b squared is 5. So that's my other denominator equals 1. Okay, now you can pause the video and try practice number 3 and number 4. Hyperbolas. Hyperbolas are, well, ellipses are the points that when you add the distances to the two foci, it's a constant. For hyperbolas, if you subtract the distance from all the points on the curve to the two foci, the difference is a fixed number. It's a constant. Okay, so here we have F1 and F2, which are the two foci, and then the x-intercepts are called vertices. So this is negative a and a. Okay, these are the vertices. And then since the curve, goes this way, it doesn't really have the other intercept. You have just x-intercept, no y. So how do you decide the other variable or the other denominator? Actually, the curve have asymptotes. the curves gets closer and closer to straight lines. So these asymptotes are y equals b over ax plus or minus. So here the asymptotes always happens at pretty much, you set this equals 0. Ignore the 1, make it 0. And then you have x squared over a squared equals y squared over b squared, square root everything, x over b equals, x over a equals y over b. Then we want to express y, right? Y equals b over ax. Then you do plus or minus where you want to do it here. But on the other hand, if you start with y squared over a squared minus x squared over b squared equals 1. If you have something like this, since the right hand side has to be positive, when you switch these two terms, you can't just say, let me multiply by a negative 1 and, move them back, because your right hand side will be a negative number, which is not allowed. Your right hand side has to be 1, positive. So if y squared term happen to be in the front, then y squared term is front. It's positive. Then the curve will look like this. Okay, those are the two curves. Again, it could be sideways, it could be up and down. It is sideways when the positive term is x squared term, and it's the open upward and downward case if the positive term is y squared term. And then I don't really switch the asymptotes from y equals plus or minus b over a to the other way around. For me, I feel like just set it 0 and solve for y. We know how to graph straight lines. So make it y equals kx. I think that's better. Now look at example. Again, equation is given. We want to graph it. We need 1 on the right hand side. So that's what we do. We divide everything. This time, again, you have x squared over 9 minus y squared over 16 equals 1. And, oh, by the way, I forgot to say the foci. The foci happens at C, which is the sum of a squared plus b squared. Okay, so this is positive. That's my vertices. Is 9 square root 3, but happen on x coordinate. So I have a squared equals 9, b squared equals 16, and c squared, this time, since it doesn't really matter which number is higher, the positive term is going to be where the vertices are. Then the other number, which might be positive, might be higher, might be lower, will just be the second number. So when you put them together, you don't know which one is higher, you can't subtract. So here you are going to add them. 9 plus 16, which is 25, which means c equals 5. Okay, and that means, again, the foci happens on the same axis as the vertices. It's just that in hyperbola, the foci are further than vertices. So what did I want to say? I want to say the foci is plus or minus 5, 0. Then if you sketch the graph, I wanted to say the asymptotes. X squared over 9 minus y squared over 16 equals 0, or, well, let me do it anyway. X squared over 9 minus equals y squared over 16. You square root everything. This is x over 3 equals y over 4. So y equals 4/3 x. That's the asymptotes. I have the vertices, negative 3, positive 3. And then I have 1, 2, 3, 4, 1, 2, 3, 4. Slope is 4/3, positive and negative. I keep forgetting it. So I'm having 3, 4. This is 3, 4. I have one straight line, and then 3, 1, 2, 3, 4. It's like here. I have the other line. This is y equals negative 4/3 x because it's falling, and this is y equals 4/3 x because it's rising. And then you just draw the curve that passing through the, have the asymptotic behavior, and meanwhile pass the vertices. So one piece and two piece. That's how you get the graph, and also you get the vertices and the asymptotes and foci. Oh, I didn't draw the foci. I'm having 3, then keep going, 4, 5. So, well, same argument. The distance, I said in the very beginning, you get these hyperbolas because if you measure the distance from the point on the hyperbolas to the two foci, the difference is fixed. So here we are comparing, what should I call them? F1, F2. So for any point, let's just try the vertex. This is one distance, this is another. This is another. What's the difference? They cancel each other. You just get the distance between the two vertices. Again, that's 2a. So the sum distance from the ellipse and the difference distance from the hyperbola are both 2a, which are the distance between the two vertices. Finally, we want to recover the equation of hyperbola. And I have foci is 3. First of all, that's C. And vertices is A. Then C squared equals A squared plus B squared. 3 equals 2 squared plus B squared, 9 and 4. So B squared equals 5. Or B equals plus or minus radical 5. You don't really need this because you are going to say since the vertices are 2 are on x coordinate, so the A is the vertices is on x coordinate and x squared term is positive. Then the y term has to be negative with the B that you found, 5 equals 1. So, A is 4. A equals 4. Then the y squared over the B, which is 5, equals 1. That's the equation. Okay, now you can finish practice number 5 and 6.